Hi, it's Christian Young here from Impress Solutions. I'd like to take the time to talk about some of the requirements that we like to ensure are included in our critical control performance standards. There's a lot of talk across industry at the moment about performance standards, and hopefully by sharing this information, it will help you or help your business. So on this particular slide, this is the first of 3 slides. Here is some key information that we like to ensure is mapped out for a critical control performance standard. You can read the words here. I'm not going to cover each in detail, but I'll just touch on a few ones which I believe are probably pretty important. So for example, first and foremost, what is the objective of this particular critical control? If we do not define the objective, then everything else almost becomes redundant or isn't focused and doesn't match up with what we want this critical control to achieve. And generally, an objective is a combination of an action and a value. So, for example, fire protection systems will initiate within X number of seconds and cover X number of distance or area or something like that. Pretty poor example, but you probably get the gist. Some other ones there, so availability and reliability, generally expressed as percentages. So again, using that example of fire sprinklers, what availability do we want? Well, generally you probably want 100%. What reliability? Probably 100% as well. Survivability, that's an interesting one, more catered to mitigating controls as opposed to preventative controls. So they need to be able to survive a damage event because they still need to function post the release of the energy. So for example, for an underground coal mine as a scenario, if there was a fire or an irresponsible atmosphere created, we would need these self-contained self-rescuers that the miners wear on their belts to survive those events because we want to put them on as soon as that release of energy was experienced. Dependency and compatibility, generally not thought of so much, and this is where your change management processes really can help you out when you're looking at designing or implementing new critical controls. Really want to make sure that's evaluated. You would hate to have a circumstance where you thought the critical control performed as intended, but due to some compatibility requirement that was unknown or unidentified, it actually didn't. Redundancy, sometimes we don't think about that. So if it fails, is there anything else left? Or was it all just wholly and solely focused on that particular critical control? And timing. So this is probably one that's only I've recently come across and started to think about and embed. This is an example for an object type control. But what is the inputs or the signals to ensure the critical control initiates its application? Sometimes we don't necessarily think about that. And once we identify what that particular criteria is, we can put in place strategies to monitor to ensure that input signal, is it being followed, is it being applied? And if not, well, what do we need to do differently to make sure it is? So once you've defined those list of requirements, then you can think about some other things here as well. So for example, what is going to trigger a review of the particular critical control, all these performance criteria? The classic case is if we have a critical control that fails or is implicated in an incident, generally do an incident investigation to dive deep to work out, what went wrong in relation to the critical control and what do we need to do differently. But there could be some other examples. So for example, if it's an engineering control and the manufacturer issues a recall, then to me that would be a performance trigger to go, okay, well, let's shut that down and work out what's going on, what do we need to do differently. Verification activities. So I'm sure a lot of people do this. There's a whole host of things to consider inside setting up verification activities, but really that's in place to ensure the control is working as intended. Failure mechanisms and prevention strategies, again, not as often thought about. Could also be called erosion factors as opposed to failure mechanisms. So what are all the different ways that the critical control could fail or erode, and what do we need to put in place? So what are those prevention strategies to stop that from happening? And that's where your verification activities would also come in, because we're looking at those aspects as well. And control effectiveness assessment. Not necessarily thought about as often, or maybe as prevalent as should be. If we say this critical control is critical for this material unwanted event, for its prevention or mitigation, then we really want to be absolutely clear on how it's performing and have some type of effectiveness assessment set up pretty much on an ongoing basis, or at the very least a routine basis. Because if it's not performing as intended, then again we want to do something about it. And some other elements that I like to consider as well is, so the verification activity is an example. What's a smart activity? How can we be absolutely clear on who does what by when in relation to that? There's also some activities to support the actual performance requirement itself. So for example, if the fire protection system should be 100% reliable or available, then what are the actual activities that are performed on a certain frequency to ensure that? So it could be the fire protection specialist goes around once every 30 days and does a test to verify. So that could be an example of a smart activity. Ownership is key. We really want to be very clear who owns what. Certainly if we're starting to map out a lot of different requirements, does it all go to one person or multiple different people or roles within the organisation? So one, the ownership, then we know who's accountable, but two, for the owners, then it's clear to them what are they responsible for and know about, and then they can monitor and measure as well. The last dot point here is really around those integration with other systems. So for example, we talked about the fire protection system, the fire sprinklers being 100% reliable. Well, what system ensures that? Generally, you might think about a maintenance management system where some work orders might be set up once every 30 days or quarter or whatever it is, that that job is actually executed and the system drives that to ensure that happens. Similarly, there might be some stuff in the safety and health management system that defines some act or behaviour type controls. Where is that written? How do we know that people understand that and ensure that that's particularly followed as well? And there could be some other systems there, action management system, there could be some HR things, etc. So very brief, but I think it's important that we share this type of information in the hope that we can all improve the development of our performance standards. And so hopefully this is of value to you. Thanks very much for listening.